Okay, let's continue our discussion on classification by engineering behavior. So, as mentioned, we have two classification systems. One of those is ASH2 classification system, or this is what we call the American Association of State Highway and Transportation Officials. This system was developed in 1929 and has been revised several times since then. So for this ASH2 classification system, this was divided or classified into 7 groups from A-1 to A-7. So cells are more than 35% of the particles passing through a number 200 sheave are groups A-4 through A-7, and a group which is less than 35% pass through are A-7 to A-3. So how do we use this ASH2 classification system? Of course, you are provided with a table. So you are given with a table wherein you could have classification. There is what we call group classification. And based on the group classification, you could specify or you could classify the soil sample. So as mentioned, this is group from A-1 to A-7. So there are 7 groups for this classification. So how do we classify the soil? So you are given with the group classification. It can either be a sheave analysis given with the passing percentage on the number 10, number 40, or the number 200 sheaves, or you can be given with a characteristic of fraction passing number 40. It can be either be liquid limit or plasticity index, or you could have your, okay, how to use this ASH2. If you are given, for example, with the sheave analysis, so you simply have, for example, you are given with the number 10. So you just have to identify it. It can be, for example, in number 10, you are given with 40%. So you just 60%, for example. So on number 10, that is 60% passing. So if you're going to observe the 60 for number 10, the maximum is 50%. So meaning to say it cannot be classified on this A-1-A. So you try to move on to another given classification. For example, number 40. For example, you are given with a 40% passing. So from A-1-A, it will not be classified here. So move on to the next. We are given with A-1-B. This is 50 maximum. So meaning to say it can be classified under A-1-B because your number 40 sheave analysis passing is 40%. So since it passes through, it was classified based on A-1-B. So meaning to say for that soil sample, that classification is A-1-B. However, if it will not pass through number 10 and number 40, it cannot be classified among this classification. You move on to the next given, which is number 200, for example. Then we try to classify based on this given data. So if it passes through whatever is given, so that would be the classification. For example, if it does not belong to any group of this, from number 10, number 40, number 200 given percentage, you move on to the next given. It can either be a liquid limit or plasticity index. Once, for example, it passes through the minimum requirement for the liquid limit, so meaning to say you can use that as your that percentage to be used to classify the soil sample. If it doesn't pass through the liquid limit, you move on to plasticity index. So that's how you are going to make use of the ASH2 classification system. Basically, for this one, once you are given with the sheave analysis and the liquid limit and plasticity index, for as long as it passes through on the sheave analysis, you can easily, you can immediately identify the soil classification on the number 10 or the number 40, since then you're going to stop with identifying the soil classification of that soil sample. So, however, if it doesn't satisfy, you move on to the next given group classification in order to classify the given soil sample. So that's how you're going to use your AASHTO classification system. So basically, for the AASHTO classification that was present in the given table, it is basically there are 7 groups. Under those groups, you could identify the different variations on how you're going to classify your soil sample. So those soils are mostly silt and clay type materials. So the classification system is based on the following criteria: the grain size, meaning to say the gravel, the fraction passing is 75 mm sheave and retained on the number 10 US sheave. Then for the sand, you have the fraction passing of number 10 US sheave and retained on the number 200 sheave. And for the silt and clay, the fraction passing the number 200 US sheave. Then of course you have to identify plasticity. So the term silt is applied and the fine fractions of the soil have a plasticity index of 10 or less. The term clay is applied and the fine fractions have a plasticity index of 11 or more. So of course you have to identify if there are presence of boulders that you encountered on your on the soil sample itself. So to classify a soil according to the table that was presented on AASHTO, one must apply the test data from left to right. So, okay, what we have done a while ago, you are given with an illustration on how you're going to make use of the table. You read that one from left to right, and the process is through elimination. So, if the first group from the left into which the test data fit, fit is the correct classification. So you just have to identify the soil classification based on elimination process. If the given group classification satisfy on the requirement on the AASHTO classification system as you read from left to right, then that fits now your classification for that particular soil sample. So basically, the AASHTO is being used in highway construction. For example, in the DPWH, they have the blue book, and on that blue book, they are referring to, they have modified the blue book, and their reference material is the AASHTO, the American Association for State Highways and Transportation. So based on that, that is now the significant use of the value of what we have processed on Atterberg limits, meaning to say on the AASHTO, on the blue book of the DPWH, they make use of the plasticity index and the liquidity index or plastic limit or liquid limit. So there are references on how to classify your soil sample that can be used as subgrade material, base coarse material, or sub-base coarse material. Because on the construction of highway, what we have, if you're going to observe, okay, as a common individual, what we have seen is the pavement, the concrete or the asphalt that we step on. However, aside from that, on the layers below that ground surface is you have different layers that we call as subgrade material, base material, or sub-base material. So definitely, you have to identify what soil can be used as subgrade material, what soil can be used as base coarse material, what soil can be used as sub-base coarse material. So to identify what materials or soil materials that can be used for that particular layer based on the laboratory test. So there is a range specific. If the value for plasticity index is this one, so based on their blue book, it can be used as sub-base material. If the liquid limit is between this range, according to the blue book, it can be used as subgrade material. So that is now the significant use of the test that we have done on the Atterberg limits. So basically, the AASHTO is being used for highway construction. So to evaluate the quality of soil as a highway subgrade material, one must also incorporate a number called the group index with the groups and subgroups of the soil. This index is written in parentheses after the group or subgroup designation. The group index is given by this equation. So there is a formula to be used to find the value for the group index. So if you wanted to know if you wanted to know, to evaluate, to assess the quality of soil that can be used as a highway subgrade material, you are going to identify or solve for the group index. So that is our GI. So we have here the presence of the parameters F sub 200, which has percentage passing through the number 200 sheave. We have the liquid limit and plasticity index. So in general, the group index is inversely proportional to the soil's quality as a subgrade materials soil belonging to groups A-1 to A-7. So meaning to say, for the lowest, the value of the group index, the good the quality is the soil. So if the quality of the soil is very low, if the group index is very low, meaning to say the value of the group index is very low, then there could be a high good quality of the soil. So that's it's inversely proportional. The value of the group index is inversely proportional to the soil's quality to be used as subgrade material. So we have here a sample problem. So basically for this is the application of the AASH2. You are given with the number 210 sheave, which is 42, number 40 sheave, 35, number 200 sheave, that is 20%. So you just have to make use of the AASH2. You read that one. For the number passing of number 10 sheave, if it passes on the number 10 sheave, so that ends our classification for the soil sample. For example, at number 10, our actually I think the maximum is 50, so this is 40. So you could have your this can be classified. It will satisfy our number 10. So the liquid limit and plasticity index of the minus 40 fraction of the soil are 25 and 20 respectively. So classify the soil by the AASH2 system. So for this one, so you're going to have, you start from the left to right of the table, so it falls under A-1-B. So for number 40, the maximum, if you're going to observe on our table, number 40, the maximum is 30 max for A-1. Our given for the number 40 in the problem was 40. So at A-1-A, it will not fall on A-1-A because the maximum is 30. So A-1-B, it will fall under this because the maximum is 50 and we are given with a 40%. So meaning to say, we could classify the given soil sample as A-1-B for this particular example. So we could easily identify our soil sample as A-1-B based on our liquid limit, based on the given AASH2 soil sample. And of course, we are given with our we have the maximum plasticity index, which is 6. So you could actually identify using the number 40 for this that the soil sample now is A-1-B because it satisfies the minimum requirement, which is 50 maximum, and we are given with 35. So it can be included on A-1-B for this particular example.